All right, so thank you. I hope you are having a great time tonight. Tonight I'm going to talk to you about a hobby project that I have currently, and it's all about building an arcade with Android, so using an Android application. Quick intro about me. My name is Eric. I am an Android developer since nearly 10 years now. And since last year, I work for Transit. At Transit, we are building a great product to help people in cities commute using public transportation. And our mission is to make cities more car-free by facilitating these alternative of public transportation. The agenda for today. So we're gonna talk first about how I discovered a smart lighting product that you see here. How I enjoyed it so much that I wanted to search for available SDK to get more control on that. How I ended up making my own Android library. Some various experiments that I've made through that process. And then eventually, what about a game? To add more interaction, so that became one of my wish. And finally, how I eventually added some controller inputs to that. Also, at the end, I'm going to talk about some future improvements I have for this project and other ideas as well. So first, what you see here, the product is called Twinkly Squares. It's a matrix of pixels. You can find that on Amazon, and it's sold at Best Buy as well. So initially, I had received a gift for Christmas in 2022 from my wife, and it was a LED strip from Twinkly. And I found that the mobile app was really reliable, the onboarding process, and you know, like smart lighting products, sometimes they're not all equal. Sometimes you get some errors while doing the initial configuration. But that product gave me really a good impression, and I thought it was really well designed. So I decided to buy this product, and starting using the official feature that can be controlled through the official mobile app. So what it is about, you have a master tile, which is here. This tile is like controlling the whole unit. It's USB-C powered. Internally, it's using an ESP32 microcontroller. That's a microcontroller that is very popular, where you have Wi-Fi and Bluetooth capabilities. And it's a lot of people use that for doing their own project and for connecting lines. On the master tile, you have 4 tile cables to connect the other tiles. And all the others, they are extension tiles, so they act as a secondary tile. And each of them have 2 parts. So one of the parts is grabbing the power and the data from the master tile in some way and distributing to the next one. On a single unit, you can have a maximum of 16 tiles. So one master tile plus the 15 extension. One tile, if you see here, it's a 8x8 pixel for a total of 64. The current configuration, so I have 9 tiles here, and the dimension are 24 per 24 pixel, and it's a total of 576 pixel. And the mapping for the pixel is done through the official app. When you do the initial configuration, you can remap them after. I have a square configuration, but it can also be in a rectangle or other as well. This is what you see in the official app when you have done the mapping, so it's going to show you how it's done. There you see on the second screenshot, it's another product of Twinkly, so this is more for LED strings. So yeah, it allows to do like mapping like that. The main features through the official app, you can display scenes, you can import animated GIF, and it's going to pixelize them, and actually it can resize to fit for, like this unit, a 24 per 24 dimension. You can also display a single color, like what you see here. It can also be sound reactive. So Twinkly, they sell some kind of Wi-Fi microphone that you plug, and it's going to just broadcast the decibel and other data across the Wi-Fi network using multicast UDP, I think. So all the Twinkly products can react to that. So I had a lot of fun during many months using this. Eventually, I was curious to try doing more, so I started looking at available SDK. Unfortunately, no official SDK are available, but there is, however, an on-device API that exists, and it has been reverse engineered at some point, and now various client implementations can be found. This is a list of many client implementations. One of the most popular is XLED. It's a Python library. So I did try it with a friend during one afternoon and was really satisfied about how it was reliable and like the potential of what you can do more. And especially one thing is the real-time mode where you can really send frames and really get control over doing what you want with that. Through that list, I saw that there is no Android SDK. So I wanted to start doing my own library. So my hypothesis was, could I be able to successfully create an Android SDK that can update frames fast enough, so with a low latency, over a long period of time, so stability is am I going to lose, like, am I going to run into a session expiry at some point? Is my process going to be killed? And also, will I experience lag? So is the performance going to encounter some problems? So to test these hypotheses, I started looking at the implementation requirements. So what I actually need to send real-time frames. So it's really, there are two parts. So the first part is implementing the REST endpoint. Three things that must be achieved through that is getting an authentication token, and then the pixel layout. Because the pixel layout, we want to work in the Android app with a human readable representation where the first pixel is actually the top left and the last one the bottom right. But internally on the device, it's not indexed like that. And then after, there is a call also on the REST endpoint to switch to the real-time mode. That when we have switched to that mode, we can then start sending UDP packets to update the frames and the colors of this pixel. So actually, this is how I started creating the background service with the necessary stuff to make it a foreground service that is going to keep the device awake even if the screen closes. Also implement a retrofit client instance, hold the authentication token, and also all the pixel representation, the mapping itself for the index, human readable index, and to the internal mapping. Compare the latest pixel structure with the previous one, so we don't send over and over the same structure, the same content if nothing has changed. So this is the code that was necessary to make that service really working in foreground persistent mode and doing hard work, hard network transfer without being killed. And actually, what you can see here, this is the function where actually the service starts, the wake clock is acquired, and then I enter this kind of while loop where either I proceed to the authentication or redo the authentication if I lost if the session has expired. And then the other part of that loop is really to send actually the frame at a regular interval. Here it's set with a delay of 25 milliseconds. So every 25 milliseconds is going to resend the frames under some condition. The first part is to proceed with the, like I said, so we have the REST API authentication, fetch the pixel layout, set up the real-time mode. Actually, this is how the REST client, these are the resources that are called on the REST API. This is also, you see the just the configuration process with the authentication and switching to the real-time mode. And then for the UDP frames, so the rules that I said that there are some conditions. So every 25 milliseconds, I want to send frame if the pixels have changed. If they haven't changed, I will wait until 10 seconds and just force an explicit retransmit of the pixel structure to avoid leaving the real-time mode, because if you stop sending UDP packets, eventually you're going to be kicked out of that mode and return to the initial mode that was previously set. Could be, for example, the single color here. How a UDP packet look like? Two important things in that. We have to send the authentication token and include it in the UDP header. And also, the other thing important is that we must provide the index of the frame number. And here's the thing. You see it that a frame fragment size is limited to 900 bytes, excluding the header. So, and for the RGB of one pixel, it's using 3 bytes. So if you divide 900 per 3, you end up having a maximum of 300 pixels per UDP packet. So what it means is that we have here 576, so we need to send 2 UDP packets to be able to fill the whole board. Actually, this is the function here that receives the authentication token, the frame number index, the pixel mapping between our human readable and the internal mapping, and then actually the pixel content itself. So we increment with the offset, and we build the frame buffer progressively, and then so when we reach 900, then we proceed to send it. So once this is done, actually, in my Android app, I want to have this kind of more user-friendly approach of working with a matrix. So I created this board class where I specify a column size per a row size, and then pixels are initialized. And I added all sort of function to set a pixel color at a specific index. And interesting thing, I asked GitHub Copilot. So from just starting writing the function names, it was able to identify that I'm working with a 2D matrix structure, and it was able to just do auto-completion. So for example, I asked, give me the edges, the top, the 4 corners, and it was able to do the good, set up the good calls to return that. So now, experiments, and I think it's time to show you that. So one of the first experiments was just to compare the 2 frames. So you see on the first frame, it's identified in red. So these are the pixels that are controlled by the first frame, and then in green, it's the one on the second frame. On the other example here, what you can see, I think I'm going to plug my PS4 controller. It's going to be more helpful to show you. All right. I'm going to keep it like that so it doesn't fall. So I can really control like that. So it helped me validate that. Shit, I have some lag. But this, I did initially all the tests with a Pixel 5 device, but now I have a Galaxy S10, and it's not as good for that background service. But you really can see that I can move over. And what I have actually is with Jetpack Compose, I just built a grid. And it's like if I was moving with the keyboard through all the Canva, and it's just assigned to every pixel. So every time I just clear the whole board, reset that to black color. Black color means that they are turned off, and I only send a red pixel at a time. Then my next experiment that I did, just gonna find that for now. So my first experiment, so I told you about these functions to get the corners and the edges. So I did this little script like that. So I was able to line these up. Second experiment, I wanted to be able to show a bitmap. And actually what we do for that is that you can take your bitmap, resize it to 24 per 24 pixel, get the byte array out of it, and it's going to return you the integer representation of each pixel color. And then you just have to transfer that in your frame, and that's pretty much it. Then I wanted to take another bitmap, but animate it. So here what I do is a translation of 1 pixel in the down direction. So, and also with that, GitHub Copilot has been really helpful. You see that I have some lag here. That's something I did not really experience at 25 milliseconds delay on the Pixel 5. It's kind of slower with the S10, so maybe probably moving that up maybe to 30 or 35 milliseconds of delay, I think it would work better. So it really depends. Not all phones are equal when it comes to background service at such a low latency, I think. Next experiment, actually this is the code where I do this translation. Next experiment was to display text. I'm just going to clear it. Yeah. So what I do with that, and it would need improvement because you see really the S character, it's like it goes a little bit down 1 more pixel. So I'm not an expert with that, but actually what I do, I paint a text on a Canva. And so I am able to fit like around 4 characters like that. If it's too small, it doesn't output correctly on the board, so that's why it's so big. I need to find more efficient way to display fonts on the board. Then experiment number 5. What I did is ask ChatGPT to generate me game algorithm. So I asked to generate a Tetris algorithm like that. So it generates random block and it transitions down like that. So it's part of the code. So most of the code is generated by ChatGPT. It was not perfect, took maybe 30 minutes to 1 hour of integration with my matrix. But when you ask ChatGPT, generate me this game algorithm for a 2D matrix, it's able to do most of the work correctly. I was really impressed. Then I decided to ask ChatGPT for another game algorithm, which is a battleship game. So what it does is I guess all the positions in, I play it randomly accelerated. So it's just going to play a battleship game, and it's going to end up hitting all the ships.
The best player, eh?
15 seconds left.
Are you sure?
It's random, it depends, sometimes it's faster. There was some lag, yeah, definitely. So now the game is completed. So I really like these kind of experiments, but they were only animating. So yeah, here's the code very quickly. But I was only animating stuff, and I was like, it's missing some kind of interaction. So how about doing really a game where there is also some kind of input with that? So I thought about starting with a small game. That's actually what I'm working on right now. And it's inspired by this tug of war game where you play on the beach or in camping, and you have 2 teams. You need to pull the rope, and like until one of the team you pull enough that it's coming closer, and then you win the game. So that's pretty much it. So I started doing my game implementation, creating a class where I control the score. So the score, actually I'm going to switch the app because it's on a different one. And I'm going to plug the controller again. And now the game starts. All right. So the game starts at the score 0, and it's really outlined at the middle. Since we have an even number of pixels, I start with 2 lines. So if you are on team A, you increment the points higher than 0. If you are on team B, it's going to decrement in the negative values. And the goal is to reach the edges. So if I click on that button here, I give points to one of the team. If I click on the other. So it's really become some kind of fight like that. And eventually, team is going to win. So if I reach the edge, then the game stops. And I got to start the game over like that. And then I can play again. Voila. Player interaction here. So I have functions to give point to either team A or team B. And what I do is when I have the score, there's also some kind of while loop which every 10 milliseconds is going to just take the score and like take the state of the game and generate the pixel matrix from that and then send it to that other loop which runs every 25 milliseconds. So yeah, that's the result. Initially, I didn't have any game controller input. I just added some buttons, but simply you can plug it through the USB port as an input and detect the key codes with that. So here we see with the on key down event, I check that my source is a gamepad, and I check for the 2 key codes, 104 and 105. They correspond to the L2 and R2 buttons, and then with that I'm able to add scores to one of the team. Something that I would have liked to show you tonight, but shipment is a little bit late, unfortunately, but I ordered these arcade buttons. So my hypothesis is that it comes with a controller with a USB wire, and the idea is I think I can simply plug it and identify the key codes and map it. So that's one of the next improvements coming very shortly. The game improvement as well would be to modify the layout to have it maybe more long, more rectangular for harder games. Maybe give the possibility to adjust the edge of the game if it's too hard, so the game can be less complicated, faster. The ability also to pause the game would be nice. Add animations before the game starts, such as a countdown, and also like a trophy animation maybe at the end. Also support 2v2, 3v3, and 4v4 game in parallel, so you could have lines where you play against a player facing you, so we can play like a total of 8 players at the same time. That would be very nice. Add a leaderboard also, where you can enter your initial, like these classic arcade games. And eventually what I would like to do is build some kind of tabletop arcade with that setup with a plexiglass table where you can maybe put your drinks at the top and the buttons could be under. So that's my idea so far, and yeah. And another idea on my bucket list, which is also using a Twinkly product. This one is called the Matrix. It's a curtain of light. So these are an array of string LED strings. And so it's supposed to work a little bit like a matrix, set up like that. I did order 1 unit. The problem I'm encountering with that is that the mapping is with the official app is kind of different. Using the controller, when I navigate the pixel, it's correct on one axis, but it goes in zigzag. So there's some kind of custom mapping that I will have to do over the mapping just to override the pixel configuration. So it's going to take more time, unfortunately, but it's really possible to reach, I think, my goals with that. And I'm really happy that other products work as well with what I've done so far. So that's really nice. I was really happy about that. And I didn't have to return the product. So that's cool. The idea eventually with that, if I get that working, and it's inspired a little bit by a talk that Etienne Caron gave 2 months ago where he demonstrated with OpenCV how you can recognize some object, people in a room. So the idea would be to detect faces, crop them, pixelize them, use the correct color mapping of these pixels, and transfer it to the product. And then maybe with that add some other animations around, maybe other faces as well, do some sort of interactions. And once if I'm able to validate that this can work, well, then would be the time to invest to extend the layout of that product to a setup of 200 per 4D lights. So a total of 2,000 lights. So I think with that, I would have something big enough to represent really faces and stuff, other objects as well. I think the one I have right now might be too small to do that. So eventually, yeah, I would like. It needs, before I invest more money, I want to make sure it works. So yeah. So yeah, that's pretty much it. References. So. Website for the official Twinkly website, the SDK documentation from the community. A lot of code that you saw today were inspired by ChatGPT and GitHub Copilot. And the arcade buttons that I've shown, if you search for SJ@JX Android on Amazon, you're going to find a lot of arcade buttons, configuration that you can find. Yeah, so questions, and thank you in advance.